when I work with power series, I find it's pretty helpful to list out the first few terms of the series to help wrap my brain around it. So I'm going to do that for each of these. I'm given these two power series and I want to subtract them. So I'm going to write down C first few terms. If I plug in n equals 0, I'm going to get a 1 over a 2 to the power is x to the power 0, so that's going to be a 1. So first term of this one right here is 1/2, and then we plug in n equals 1. So if I plug in 1, I'm going to get 2 plus 1 is a 3 in the top, and in the bottom, I'm going to get 2 plus 2, which is 4, and then x will be to the power 2. And then I'm going to plug in n equals 2. We plug in 2, so it looks like the numerator is going to be odd and the denominator is going to be even, and we're going to just jump through the odd and even numbers in order. So my numerator is going to be 1, 3, 5, denominator is 2, 4, 6, and x has always an even power, so this one's going to be x to the 4th power. Do one more. So again, this is n equals 0, 1, 2, and now 3. 6 plus 1 is 7 for the power. So 1, 3, 5, 7, that fits the pattern I was seeing a moment ago. And if we plug in 3, 6 plus 2 is 8. And 2 times 3 is 6, so it's going to be x to the 6th. And we just keep going. Let's do the same thing for this s of x here. So I'm going to find this one. I'm just going to list them underneath, starting at n equals 0. So the first one for n equals 0 is going to be a 2 over a 3. And then if n is 0, I'm going to get x to the 1st power. And then we're going to have a plus. When n equals 1, I'm going to have a 4 over 5. And this will be 2 plus 1 is x to the 3rd. All right, so I can see a pattern starting developing. The 2n plus 2 is going to be even. The 2n plus 3 is going to be odd. And we have the sequence now, 2, 4, next one's going to be 6. 3, 5, next one's going to be 7, and the power is always odd here, so that's going to be x to the 5th. Let's do another one. For 3, we're going to get 8 in the top, and 9 in the bottom, and I'm going to have an x to the 7th. And I am asked to subtract these two series. Okay, so pretty much have them set up to subtract. All I have to do is take the opposite of each of these guys here and put them together. All right, what's the new series look like? Well, I'm going to start off with the 1/2, then I have a minus 2/3, x to the 1. And then I'm going to have a plus 3/4, x squared, right? Put the powers in order, minus a 4/5, x cubed, and then a plus, x to the 4th should be next, 5/6, x to the 4th, minus 6/7, x to the 5th, and so on down the line. And I'm starting to see a pattern developing here. The numerator is 1, then 2, then 3, then 4, then 5, then 6, and so on. So if I start counting with, say, n equals 0, and then 1, and then 2, and then 3, and then 4, the powers line up nice. So I'm going to say this is the sum as n goes from 0 to infinity. For sure, I'm going to have an x to the power n. First one gave me the even powers, second one gave me the odd powers. Now I have all of the powers of n. Now my numerators, let's see, if n was 0, I get a 1 in the top. And if n was 1, I get a 2 in the top. So my numerator is now n plus 1. And my denominator is always 2 more than n, right? 0 to 2, 1 to 3, 2 to 4. So my denominator is n plus 2. And now I have to squeeze in the alternating part. So that means there's going to be a -1. And I want the first one to be positive, the second one to be negative. So it was 0, positive, 1, negative, 2, positive. So that would just be -1 to the end. So that is now the series for the difference in these two. And again, the powerful thing for me is write out the first few terms and then start playing with it and looking for a new pattern. And I find that to be useful almost all the time. Thank you.